Hi there, this is Mikhail Cedrus from CIT381, um, Business Intelligence Analytics, and this is my game theory and artificial intelligence project. I've decided to do a rock, paper, scissors project and to code it in Java. Okay, so I just want to go through some of the code that I wrote just to give a little bit of a background into what I was um, what I was thinking of doing. Okay, so I initialized a few global variables. So the input and array list, the probability variables, and my AI's decision. These are all empty, just so that I can access these in separate methods. Um, okay, so let me go to the main method. I do a do catch just to catch any exceptions that pop out, so that it can just be a little bit more well-rounded program. I do a do while loop, so that the games can constantly be reiterated after each game ends. Um, I call the play game my main calling method with the elements, um, the global array list as the parameter. Okay, so let me go to the play game method. I initialize the game number just to show what number game we are at, just to keep track of it. I start with my input. I ask the user to input rock, paper, scissors, um, or even exit if they finished leaving just because of that do while loop so they can exit. Um, so I take whichever weapon, the weapon that the user brings, and I add it to the elements array list. Um, this will later go on into a hash map. Um, I then call the count frequencies method that does most of the calculations for me. So if I go to the count frequencies, yeah, I initialize my hash map that I mentioned. I start with 3 beginning values. I'm not sure if this is very legal, but this is just to give a start to the program, or else there'll be errors throwing around everywhere. I chose the ones just because it's equal. It's the same value. So when the probabilities come, hopefully it's not too bad. Um, so this for each loop, I wrote just to get the elements from the array list into key value pairs, so that I can determine, especially with a hash map. A hash map doesn't take any duplicates, so I can get how many rocks there were, how many papers, how many scissors that the user entered. I then have a total variable here so that I can add up how many elements there are in total for the entire thing. So this will help me with these two will help me with the probability section over here. So I set up my rock and my paper and scissors probabilities. So I go and collect the rock key. So then I take the rock key, the rock, I use the rock key to get the rock value. And so the amount of rocks, they are divided by the total amount of elements. Use the probability that that the user will enter a rock. The same happens with paper and scissors. This is my probability output, just for my debugging purposes to see how the program ran. Okay, going back to the play game method. Over here, I do a couple if else loops. So this is mainly if the rock probability is greater than the paper probability and the rock probability is greater than the scissors probability, then I think that the AI should then choose paper. The same goes for paper. If it's greater than rock and scissors, then I'd say the decision should be scissors. Same with the rock. One thing to note, especially at the beginning, um, a lot of the probability, um, the probabilities are similar to each other because of the low numbers. For instance, 25%. Um, so I added if the user entered rock and the rock probability is equal to either the paper or the scissors, then I'd manage to say then it's paper because of that. Um, because that probability is the same. I did the same with paper and scissors over here. I then moving on. We go to the final decision and the lethal weapon. I added them to uppercase just for aesthetic purposes, just to see where we are at in the program. So I then output what the user's choice is, which is the weapon that they chose, and then the AI's decision on that. So once that's there, I use I tally them up to see. Tally is maybe not the right word. But I take the weapon that they give and the AI's decision, and I do a normal form design for the game theory design. Um, like over here, so the real player, say for instance, he chooses rock, and the AI also decides on rock, then it's a zero, it's a tie. However, if the real player chooses paper and the AI chooses rock, then the winner is the one who gets the one is the actual player, and the AI gets the loss, the -1. So I set this up over here in my tally method, where if the user enters rock and if the AI decides on rock as well, will return a zero for a draw. If the user enters rock and the AI ends up with paper, then the AI loses and it's a -1. Else, it will be a 1 for the user to win. The same was set up for paper and scissors over here. Um, so going back here, so if the winner was 1, which means the user won, then it would say humanity won because the user's weapon beat the AI's decision. However, if the winner is -1, which means the AI, that means that you lost and the AI won, and the AI's decision beat your weapon. And if it's a 0, it's a tie with this, both tied with the same weapon. This is my exit if statement, and I go to the leave game method just to exit the game safely. To say thank you for playing as well. Okay, so now that we've done a quick rundown, I'll give you a quick um, demonstration of how it works. So, if, for instance, if I chose rock, my AI would output paper, and paper beat rock, so we lose. Now, if I go and I choose paper, then it will output scissors. If I continue putting paper, say I put paper twice, so we've lost now twice after that, and now I want to choose rock. It's gonna still continue with scissors, but the minute I start putting in another rock, it will change the paper, and it will adapt to what I'm saying. If I choose scissors now, then it will stay with scissors. Let me go to me choose another. Okay, it's still paper. Now if I choose rock, it's going to give me paper. If I choose scissors, it's going to give me paper again. And it will slowly adapt, just depending on the probabilities. So later on, once we start getting into games, say 15 plus, it starts to get quite predictive to what it's going to be. Um, One thing to note is to the one of the few strategies to actually win would be to constantly continue on with one element and then quickly switch over to another one, as shown over here. Uh, that's probably one of its only downfalls, but I'll cover that in the documentation. Okay, thank you.